Hello and welcome to an episode of RC Engine Dyno. Today I'm going to be testing the LRP ZR32X 4.1. This is the newest engine in the LRP lineup, and LRP's the 32 version is known to be a very good engine for bashing. So I'll be testing it out on the dyno, but first I'm going to check what's in the package, then I'm going to do the break-in, and finally we will do the dyno run. So let's see what's in here. So in the package you will get your manual, you will get a few stickers, you will get the engine with the carburetor attached. You will also get two Venturis. They are 8.5mm and 7.5mm, and you'll also get a brass collet. So with the engine itself, I can see that the carburetor is different from the usual LRP ZR32 Spec, so that is a difference straight off from the Spec 4. Can also see that the plug is already attached, and I've been told they are turbo glow plugs. There are turbo glow plugs on this engine. So first let's inspect the insides and see how good this engine is. What I'm going to do is going to make sure the piston is not at bottom to center, as sometimes there is a groove for the skirt of the piston to go into the back. Okay, so the sleeve comes out very easily in this engine. Okay, so the crankcase seems to be quite tight with the crankshaft. I will give it a few taps and that should loosen it. So there you have it. There's the disassembled LRP ZR32X Spec 4.1. I'm just going to have a look at the carburetor, see if it's a long needle type or a short needle type. So there's a 9mm Venturi already on there. And as you will see, it is a short needle type, which means that the low speed needle completely disengages at high speed, full throttle. So you can see there's a gap. So 9mm Venturi is standard on that. Crankshaft seems in good condition, nothing special, no ramp on here, just a standard crankshaft. There's a bit of oil on there, which is nice to see. Crankcase itself, if I remove the cover as well, just haven't. So the gasket is already on there, which is nice. The crankcase itself seems to have okay machining, nothing bad to say here really, looks okay. Piston itself, quite a large piston as it is a 32 engine, 5.2 cc's, seems quite chunky. And then onto the sleeve. So this is a 7+1 port sleeve. So we have the exhaust port, then we have 1, 2, 3, 4, 5, 6, 7. So that's 7 ports plus the exhaust port. Now what I have to say here is that they do have two bypass ports here, which they're counting as part of the port. Got some nice slits down the side there, which should improve the fuel flow. The turbo or the boost port doesn't really have much of an upward angle, which is strange. Normally they have quite a steep upward angle, but hey ho. And inside machining, I can see some marks of machining in there. Probably can't tell on the camera, but it's otherwise it seems in okay. No deep burrs or anything to note. Some oil on there, which is good. Yeah, so that seems okay. So what I will do is I will put it back together, and then I will put it through the break-in process. So for the sleeve, you just need to be careful with the groove. So you can see there's that little notch there. Just need to align it with that bit there. Now normally what happens is when you're trying to put the sleeve in, the piston is leaning to one side or the other. So what I like to do is I like to push it down gently, put the piston close to bottom dead center, and then as I put the sleeve in a little bit, what I tend to do is I turn the engine upside down and then let the piston kind of fall naturally into the sleeve. So now that I've put the piston at top dead center, you will see that it's nicely in the sleeve as well. So I push that down gently, let the piston go down as it will hit the pinch zone. Back plate on next. Make sure that you don't have the piston at bottom dead center, so move it up slightly and then put the back plate in. Just remember where the ridge goes. That's normally where the piston is meant to fit in. When I'm doing these engines for my vehicles, I normally apply some sealant just to be sure that there aren't going to be any leakages. But since I'm going to be dyno testing these engines and then selling them on eBay, I will just be using it without any sealant. Cross thread pattern, so follow a star or X kind of tightening procedure. Do one side and then the other side. Now the button head, so there are already some shims on here. I'm going to leave it as at the factory, so I'll leave all the shims on there. Now normally with these engines, they normally have some indication of where is the exhaust. I don't see anything in particular on here, but I do see a slight mark on there. Not sure if that's meant to be the exhaust or not. But I will align it to that anyway. And then for the engine, sometimes you just need to be careful with the engine heads. They have some airflow going through one way but not another. So you'll see on this LRP ZR32X, you see there is some airflow. There's some cuts down this side and that side, which means that it will provide better airflow when you're coming down that way. So that should face forwards or backwards, but not to the side. So that should allow air coming in. So I'll put it in like so. And what they normally say is when you feel it kind of tight, you go up to 180 degrees, between 120 and 180. So that's tight now, and now I'm just going to turn it. That seems like enough. Okay, so there we have it, the LRP ZR32. Now what I'm also going to do is I'm going to remove any venturis, because I want it to be as free-flowing as possible when I'm doing the break-in process, but also when I do the dyno testing. Now venturis can be painful to remove if you don't want to damage the venturi itself or the carburetor. If I struggle sometimes with bits that I can't remove, I'll normally use some pliers, but what I'll do is I'll protect anything with an old leather belt. So in this case I'll try the leather belt first to see if I can get some extra friction. And there you have it. So venturi removed, and the engine is now ready to be broken in. Quick word on safety: when I'm using my braking bench or my dyno, I always have my ear defenders on, my goggles on, and when I'm using my dyno as well, I'm using my cut resistant gloves as well. Okay, so now I've got the engine mounted to my Hudy braking bench. I've also got a temperature sensor by Prolux attached, and the apparatus I'm using is a Hipex R4 manifold and a Dynamite 053 MR exhaust. First thing I'm going to do though is I'm going to warm up the engine with my engine heater, and that will ensure it's at a nice temperature before I get it started. So here we go. Right, I've now run the engine in through 6 tanks. The 6th tank was to get the right tuning, so every throttle I did, I would use the tachometer to track how fast the propeller would be going, and now I'm going to be testing it on the dyno. So this is the moment we've all been waiting for. Now, according to the instructions, the power of this engine is 4.69 PS, which is equivalent to horsepower. Let's see what it actually does. One of the great things about these compact clutches from Ultimate Racing is that the clutch shoes are actually attached to the flywheel. So whenever you want to change your flywheel, which is what I normally have to do with my dyno testing, I can take the whole thing off and then I can attach the whole thing again. So very, very handy, because then I can just slot it on and bang, I put the nut on and I'm ready to go. If you don't want to mark your flywheel, but you want to hold it steady and you don't have a flywheel tool, or like this Ultimate Compact Clutch, you cannot use those, just get an old leather belt, stick it round the flywheel and then grab it with some pliers. This way you won't mark the flywheel. So how does the Nitro engine dyno work? Well, it's quite simple really. This is the OnStat racing dyno. What we do with this dyno is you have a slider where you mount your engine, your exhaust, your fuel tank. You have a little throttle lever which gives you the throttle for the carburetor. I've mounted my clutch bell and clutch, and I also have my temperature sensor as usual from Prolux. And what you do is you put this on a starter box to start it, and then once it's started and it's nicely warmed up, you slot it into the OnStat racing dyno. You have to hold the clutch bell to get it into position, and once that's in position you flick the dyno switch and then it will flash green, and once it flashes green you can full throttle it. Now it can record 3 seconds or 6 seconds. I'm recording 6 seconds today, and once that is done it will transfer, I can download the data to my laptop. In my next videos I will be starting a comparison table of how these engines rate against each other. Thanks for watching my video.